Hello sir, this is Sai Pravalika from CSCF section in SRIT. Topic: Algorithm for NQ, DQ and traverse the data in queue with examples. Introduction to queue algorithms. A queue is a linear data structure that follows the first in first out, that is FIFO principle. Elements are added to the back of the queue and removed from the front. This structure is widely used in various applications like scheduling and buffering. This is the queue data structure example. Insertion, that is NQ, is done at rear end. Deletion, that is DQ, is done at front end. Understanding NQ operation. The NQ operation adds an element to the back of the queue. It involves updating the rear pointer of the queue to the point to the new element. If the queue is full, an overflow condition occurs and an error is arised. This is the example of the queue with elements. NQ algorithm steps. Insert function. To insert an element into the queue, follow the steps. Step 1. Check whether queue is full. That is, rear is equals to size minus 1. Step 2. If it is full, then display queue is full and terminate the function. Step 3. If it is not full, then increment rear value by 1. That is rear plus plus and set queue of rear equals to value. Algorithm. Void insert with int value formal parameters. Step 1. Start. Step 2. If rear is equals to size minus 1, then display queue is full. Step 3. Else, if front is equals to minus 1, then front equals to 0. Rear plus plus. Queue of rear equals to value. Display insertion success. Step 4. Stop. Example of NQ operation. Consider a queue with a maximum size of 5. NQ elements 10, 20 and 30 would result in 10, 20, 30 in the array. After NQing 40, the queue becomes 10, 20, 30 and 40. DQ algorithm steps. Delete function. To delete an element from the queue, follow the steps. Step 1. Check whether queue is empty, that is front equals to rear. Step 2. If it is empty, then display queue is empty and terminate the function. If it is not empty, then increment the front value by 1, that is front plus plus, then display queue front as delete element. DQ algorithm steps. First, check if queue is empty by verifying the front index against the rear index. If it is not empty, retrieve the front element and store it for return. Then increment the front index to point to the next element. Algorithm. Void delete. Start. If front is equals to minus 1 or front is greater than rear, then display queue is empty. Else, display deleted queue of front. If front is equals to rear, then front equals to rear equals to minus 1. Front increment. Stop. Example of DQ operation. Using the previous queue state 10, 20, 30 and 40, DQing will remove 10. The updated queue will be 20, 30 and 40. A second DQ would remove 20, resulting in 30 and 40. Traversing the DQ. Display function. To display the elements of the queue, step 1. Check whether the queue is empty. Front is equals to rear. Step 2. If it is empty, then display queue is empty and terminate the function. Step 3. If it is not empty, then define an integer variable I and set I is equals to front plus 1. Step 4. Display queue of I value and increment I value by 1, that is I plus plus. Repeat the same until I value reaches the rear, that is I is less than or equals to rear. Algorithm. Void display function. Start. If rear is equals to minus 1, then display queue is empty. Else, display queue elements are for loop, front is assigned to I and I is less than or equals to rear and I increment. Display queue of I. Stop. Example of queue traversal. For a queue in the state 20, 30, 40, starting from the front index will yield, the traversal will access the elements 20, 30 and 40 successfully. This allows for operations such as displaying or modifying each element. Conclusion. Queue algorithms are essential for effectively managing data in various applications. They are commonly used in task scheduling, managing resources, and handling requests. Understanding NQ, DQ, and traversal provides a foundation for advanced data structure concepts. Thank you.